My name is Jonny Huck. I'm a senior lecturer in GIS in the Geography department. I'm a GIS consultant and I'm also chair of GISRUC, which is GIS Research UK, which is the main GIS kind of network for researchers. But it's one of the biggest ones in Europe, actually. And what Lawrence asked me to do here is talk about what GIS is, which weirdly is something I've never really considered before. You would think I would have a lecture along these lines, but I don't. So it was quite an interesting exercise thinking about what GIS is. And what I'm going to do is give you a rough overview of kind of basic definitions and so on, and then go through some examples of the state of the art. So I'm not going to go through loads of basics. I'm going to show you some of the key areas of major growth, major expansion in the field at the moment. It's quite a brief talk, so it won't take too long. Just so I know, and I'm not telling people things they already know, who uses GIS already? Okay, yeah, so about half and half. Okay. Right, so the first thing we know then, and I'm sure at least half of us already do know, is that GIS is really two different terms. Okay, and it's quite worthwhile just getting your head around this. So it means firstly a geographical information system. This is the traditional terminology, which dates back to Roger Tomlinson in the 1960s, created the Canadian Geographical Information System, which is the first ever bit of GIS software. And that is any computer-based system that can capture, store, analyse or communicate with data. And always critical there. So we often think of GIS software being things like ArcGIS, QGIS, these kind of things that do all of those things. But anything that does any of that would be perfectly reasonably called a GIS. So that's the first thing. And the second thing is the discipline. So since about the late 90s, we've had our own discipline. So I consider myself to be a GIS scientist rather than a geographer. So I'm specifically working in Geographical Information Science. And that's the discipline that concerns the kind of theories, technology, models and so on that we use in there. Right? So we have a lot of people who use GIS systems, and some of those people are GIS scientists. And just to dig a bit more into that discipline, a lot of people don't know that actually it's really founded on critical use. So it's not explicitly or exclusively a technological endeavor. Okay, so the reason this whole thing came about was that we had all the people who do the sort of thing I do with developing systems, and they were seeing new ways of getting people to use them and be involved. And there was all this kind of talk of creating informed societies and democratising the decision-making process and all this kind of thing. And it all sounded very positive, and at that point a lot of critical scholars started to get involved and started to notice GIS and really saw a lot of potential negatives, and that we needed other ways of looking at this stuff. We can't just assume that someone's software can do all those things critically. And there was a really substantial argument on this for a number of years. And if you look at people like Pickles, Openshaw, Fisher, you see all these names and a battery of articles through the mid-late 90s that kind of discuss this. And it all led to a head this kind of recognition that we needed a discipline to really look into this itself, and that created GIS science. And that really happened at the point that the International Journal of GIS became GIS Science Statistics. And from that point, it was kind of a legitimate discipline. And that's where it came from. And that discipline is extremely interdisciplinary. So I would love to hear talking interdisciplinarity earlier, because we are a great example of that. Just the main things I do and teach and read, I draw from computer science, maths, physics, particularly if you're working with satellite data, Earth observation, areas like image processing, artificial intelligence, and lots of others. So there's loads of different areas, and you can be specialist in some of these and not great at others, and that's okay. So there's loads of different ways you can get involved in GIS. Right? I'm going to talk through a few of those, picking on really some of the key kind of boom areas that I think if you wanted to get into it, you might want to look at. Right? And the first one is participatory GIS. I mentioned this in part because it's one of the things if I'm known for anything, probably this is one of them. And this is really that kind of stuff that GIS was founded in GIS science. It is collecting data from members of the public or from any stakeholder, any people really, in a geospatial way. Okay, it's a very, very valuable way. And this is from a systematic review, one of my PhD students did a few years ago. You can see the growth in this is phenomenal. Okay, so it's a huge boom area. It's well worth getting involved in. If you're looking to do things that might involve development, might involve decision making, might involve policy, this kind of thing is a really powerful tool. And this is one example of participative GIS. It's a slightly weird one. It's called Paper2GIS. This is one of the platforms that I created. And what you have here is you get a paper map, you get people to draw on it, tell you what they think, and then you take a photo of that, and it turns those drawings straight into a GIS database. So it just brings that straight off the page into your GIS dataset. Okay, so this is just one example. There's a paper about it, people can use it, it's all there. But there's millions of different ways of doing this. It's a really exciting area. And just to illustrate some data collected in one of these systems, and to mention something else I wanted to talk about is geovisualization. Right? So this is just visualization with GIS data. And you know, at the minute, there's a pretty large international conference every year, and we're reviewing papers, and this is a really big theme this year, so that's why I put this in. So this is GPS data. We've tracked with the mobile phones a few hundred people, and we've asked people to fill this in using the kind of airbrush interface on a participating GIS platform. And what they're showing, so this is a very segregated place in Northern Ireland, part of Belfast. We have Catholics who are in the light blue, and Protestants in the purple. You can see where those people actually went in this data set, and you can see where they say their communities are in that data set. And this reveals to us really good information about the kind of dynamics of this space. But what it also tells us, this visualization technique, there's no quantitative information here. We haven't done any kind of numbers out of this. And this is something that the Northern Irish government really got on board with, because you can very quickly, very easily see the interaction between these three variables just because of the way the colours are mixing. So instead of just having a bit transparent, you can see it through it. The colours actually change as they interact. Very easy to do. You can do that in QGIS, which is a free GIS platform, but it's very, very effective if slightly garish way to display data. So that's one. Data science is another one. So several of you might be data scientists, you might be involved with things like Python and R. And this is a really big area of GIS, and it's important because spatial data, you can't just take normal statistics and apply them to it. Okay? In almost all cases, your spatial data will invalidate the underlying assumptions in those statistics. So you have to get involved in the GIS literature and look into things like spatial non-stationarity and basically spatial modeling techniques to be able to get involved in that. And another quite exciting, quite big area is data fusion. Okay, so the proliferation of data sets online, taking these data sets and combining them. So here we're combining 4 data sets into one surface. And this is a belief surface for where we believe these communities to be. Right? So we have census data, some survey data, and 2 data sets I've already showed you. Very, very different heterogeneous data sets, very hard to combine in a meaningful way. What we do here is called fuzzy-based inference. And it takes all of this very different data and makes it into a continuous surface of how strongly we believe each area is associated with each community. And here you see it's not a continuous surface, it's just removed all the area in which we don't have the very highest levels of confidence. So if the uncertainty in that analysis is more than 0.1, we spin it, and this leaves us with these kind of really core areas. An interesting one like this big one here, okay, it doesn't come through well in the census at all. Okay, so it really is valuable to also get involved in all these other kinds of data sets. Another area that I like to talk about a lot is really fundamental GIS science. Okay, so it's easy to take it and do some data science, do some visualization, looking at all these different techniques, but actually research into GIS science is very interesting as well. So here's a good example. These are 4 different ways of measuring exposure to green space. Okay, this is something we do a lot. Availability is basically proximity, this is where you can see it, this is network distance to it, and this is a combination of those 2. Okay, these have been published in various different places. But the way these data sets are used is usually something like this. Okay, you get someone who gets GIS, and they want to find out about a location, right? And they go, oh yeah, stick a point on this location, it's a house, it's a school, it's whatever. And then they want to characterize that location. Okay? And you don't want to just use the data that's immediately under that point, because obviously that's quite not representative. So the point on my house would be quite very urban, but if you include my garden, it'd be a bit more green. So you get an area around it, and you summarise this area to describe this point. Right? Interestingly, that is really bad technique. So there's a really big problem with this called focal area bias. And this is something we've worked on recently. It's still actually in review and has been for an extremely long time in the concern. But the problem is, if you do that and you calculate just the proportion of greenness for this town centre versus this field in the middle of the countryside, they come out very much the opposite way around to what you expect. And the reason for this is the focal area bias basically says that this analysis is biased towards things that are further away in the shape. Okay, so there's more things over here and fewer things over here, so this looks more green and that looks more urban, which is silly, but it's true. And this is a mistake you see constantly in literature. Okay, again and again and again, can't move through it. If you look at any kind of buffer or focal analysis in the literature, it almost certainly has this problem. Okay, and the recent paper we've done have identified and tries to resolve that. So these kind of questions, fundamental questions, really, A, are exciting to look into, and B, just reminds us not to just blindly use the tools in GIS. Okay, because you go into ArcGIS and use the focal analysis tool, it will do this instead. Okay, so you've got to be thinking and give it literature and give it GIS scientists. Another good one is simulation. Very big, constantly growing. Growing slowly because it's hard, but it's very interesting. This is those capital processes moving around again. I never shut up about it. But there's some things I really want to pull out about this. So the nice things about agent-based modeling, okay, is that it helps us to A, evade another common mistake in data science, and B, can answer questions you can't answer in other ways. Right? So one, simple one. These people move just as real people move. Okay? So I can start messing with the world and see what happens. Yeah? So in this area, there are now 98 walls blocking, preventing you going between these communities. Okay? You can take those out and see what happens before we actually take them down. I can add some more in. Okay? I can add in another community. I can demolish a community. I can add a shopping centre in, but share and see what happens. Okay? So I can evaluate future scenarios using simulation. Okay? Cellular automata, agent-based modelling, and so on and so forth. The other thing that this does is it allows us to find out generative patterns, and this is a fundamental problem and a mistake we see a lot. So if you take, it's very common in science to go out, social science in particular, go out, interview 30 people, take that, and then say, right, so if everyone's like this, then that's what happens. Yeah? So kind of scale our individual findings to population level. That doesn't work in a lot of cases. Okay, these are the thing you get at the population level, what we call emergent patterns. They come as a result of individual behaviours, and not always the same result. Classic example of this is Thomas Schelling's model of segregation. You'll be shocked to hear I'm not particularly an expert on segregation. I have one project about it, and I've never stopped talking about it probably. So if we assume, so red people and blue people living in a town, empty houses and just the white spaces, right? Those people, if we say they all have a 30% preference, that they want 30% of their neighbours to be the same colour as them. Okay? Would we say that was an excessively, I don't know if racist is the right word, but is it an excessive standpoint? Is it a particularly strong viewpoint? Would it lead to a very significant level of segregation in the landscape? And the answer is yes. Okay, so what we've done here is we've 19 iterations of a simulation where people who are unhappy, so fewer than 30% of their neighbours are not the same colour as them, so they move. And this is what results. It's amazing. Okay? And the fact is, we could look at this number and say, well, we've been integrated society, everyone's fine, that's probably okay. But the reality is very, very different. These are emergent patterns. And the fact is, you cannot scale individual level behaviour to population. But you can do it if you get involved in simulation. Because we can program the things we know at the individual level, we let the agents in the model interact with each other and observe what happens at the population level. So this is a very simple example, but quite a powerful one. So it's always good to know and see and stuff. Because at least that's total segregation. We can also take this to its logical conclusion, right? So we talk about simulation. We make simulators like this that are quite simple and quite generalised. Okay, so the one I made on the previous slide is perhaps a bit more real. It's on a real map. It's people moving between real houses and real shops and so on. This one's an extremely kind of abstract one. In fact, it's the first ever agent-based model. The term didn't exist at the time. But to go further in the direction is something called a digital twin. Okay, and this is again something that's had a real boom a few years ago and still moving forwards and still quite popular and growing. So what this is where we really completely replicate a system. Okay, so simulation normally is quite abstracted, and you make it as simple as possible. Okay, you do the least amount of work to get the behaviour you're looking for, because otherwise it gets too complex and too difficult to measure. In a digital twin, we go the other way and we try and completely simulate it. So it might be that we own a building, and we have a complete simulated version of that building, and we use that to manage it and see what would happen in different scenarios. Oh, fire drill, where does everyone get stuck? Oh, this is broken down, where does everyone go to the toilet, where go to the water, whatever. Okay? If you do that for a building, you can do it for a city. So it's quite popular. Again, it's very hard in computing power. Can you do it for a city? Can you do it for a region? Can you do it for countries? You can do it for economies. There's loads of different ways to get involved in this kind of work. And it reveals loads of really interesting things that we can't get at in any other way. So simulation, definitely not something to overlook. And then finally, I can't really go away without talking about artificial intelligence. It's pervasive in everything, and GIS is no different. In fact, it's been in GIS for a really long time. We've been using it. So this is detecting huts in northern Uganda, in an unmapped area. We were delivering healthcare in that area, and we used this to map it. So we mapped an area about the size of Belgium in Uganda, so we could deliver healthcare in it. Because we started the project before we realised it wasn't mapped. That was fun. But yeah, that's the kind of thing. And more recently, obviously, large language models are becoming very kind of pervasive into everything. This is no different. So now we have people in another part of Uganda, in South Uganda, being interviewed, and while they're talking to our interviewer about injuries they've got, the AI is trying to map the places they're talking about, so we can see their journey from injury to our workshop, okay, via clinics, hospitals, and so on and so forth. And that's really helping us, because these are people who participate in GIS is a big challenge, because they're people who probably haven't seen a map before, because we don't know that area. Okay? So, you know, really powerful potential, you know, great lot of potential in AI tools as well. And that's about it. So that's the few things I just wanted to show and to talk about, kind of key areas I see as big boom areas at the minute that are relevant to what you're doing today. But GIS fundamentally is a group of technologies and a discipline. Okay, two separate things. It includes a range of different approaches, and you can take any of those. You could be, you know, competing, you could be just applying those techniques. You need to make sure you're not falling foul of some of these areas. Okay? It's rapidly developing, it's a great, exciting area to be in. And if you really look into it, fundamentals like, you know, really, it's very rare on a data set that doesn't have locations attached to it. So it's really important to get involved and come speak to you. I'm very happy if you want to come speak to me again. Unfortunately, I have to go and teach, so I'm not going to be able to stay today, but do feel free to get in touch if you'd like to talk about anything I've mentioned. And for the purpose of fairness, things I've referenced are all okay as well. Thank you very much.
If anyone's got any questions, we've got a couple of minutes of questions if anyone.
Do you have a paper describing that last example with the language model?
No, that's kind of going on at the minute. So yeah, no, we're not published anything on that. It's a bit in development really, but it's not that hard to get to that stage. The challenge we've had is because we're working in largely unmapped areas. The language model doesn't already know where everyone is. So we've been doing some work on that front. But yeah, it's relatively early stages, but a good point with the kind of the sorts of things you can do with these kind of tools. And certainly in the UK, I think you could probably do that almost straight out of the box.
Just a general question about participatory GIS. So, apart from databases that are provided from Google and maybe from OpenStreetMap, are there any other databases which can be used to access this participatory data that's out here?
So, participatory data is normally collecting more like people's thoughts and feelings and things. So, you know, it would usually be in support of something like a planning application. So, the classic early examples. Actually, where I came to it, because I used to be a wind farm developer in my first career, was, you know, well, should we build a wind farm here? And people say, oh, we shouldn't build it there, because we need to protect this area, or I don't want to see it from here, and all these kind of things. So participatory GIS is usually collecting data that specifically is the kind of spatial thoughts and feelings of the stakeholders for a particular decision, or a bit of research, or policy, or something like that. So you don't normally kind of access those kind of data sets online. If you're looking for map data, though, so the kind of volunteer geographical information, the one you said, OpenStreetMap, is the key one. So if you want actual just map data, that's non-commercial and available to anyone. There used to be several kind of different versions of that, but now that one is absolute king. So yeah, OpenStreetMap's definitely all the map reading you can, that's all. We sent all that to OpenStreetMap, and then Google took from there. It's now Google Maps and so on. So it's a great route in if you need that.
Yeah, as I told you before, I'm doing life cycle assessment. One thing that I didn't know before starting working with life cycle assessment is that the quality of the data in different regions is super different. And most of the indicators and the databases are made for, I don't know, the global north and mostly Europe. Is that something that you also see in the GIS?
Oh yeah. I mean, the data quality varies significantly. So it's not unusual for data just not to be available, or if it is, it will often come from something like OpenStreetMap, so it's been created by volunteers, and it will be very, very good in quality, and that's something we have to manage very frequently. There's lots of ways of doing that. So one is we've recently been using data from effectively colonial maps to find out about some water work we do in India, because there are no kind of maps of where these things were, so we've got these historic maps, obviously loads of errors and problems with those. We've had to come up with data processing approaches that allow us to account for the fact that they're all in the wrong place a little bit, and we try to line up with satellite imagery that isn't in the wrong place. So it's a very common problem, and the thing I like to do is really, in analysis, don't forget uncertainty. The second you take an average or what have you, you lose a lot of uncertainty. So I'm very keen on making sure that that's maintained for our analysis. But it's very common, and there are ways to solve that.
I think that's all we have time for. So thanks very much, Jonny.
Thank you.